Okay, the goal on these problems is we're going to build up a function that has these transformations applied to it. All right, so they've asked us to start with e to the x as our basic starting graph or our function, and then we're going to vertically stretch this by a factor of 2, reflect it about the y-axis, and then shift it up 4 units. Now, as far as picking out the domain, range, and horizontal asymptote, that's going to be after I've applied all 3 of these. However, let's do these one at a time because the homework question this is included in, they asked this as 3 separate individual problems. So let's go ahead and say, well, I'm going to start with e to the x. Let's vertically stretch this by a factor of 2. Well, whenever we have a vertical stretch or a compression, what's going on there is that means a multiple out in front. So we can start with e to the x. We're simply going to take a 2, our stretching factor, and multiply it out in front of the entire function. So again, on the homework, if this was laid out as 3 individual questions, we're going to answer these individually. Then what I'm going to do is put all 3 of these together. You won't have to do that on the homework, but I'm going to put all 3 of these together and build up a function, and then we'll answer the domain, range, and horizontal asymptote based on all 3 of these transformations. Okay, again, reflect this across the y-axis. So again, I'm just starting with e to the x power. Whenever we're doing a reflection, what that's going to indicate is some sort of negative being attached in. Good reminder here, the y-axis is going to be the vertical axis going on here, so things are going to be moving left and right as we reflect things about the y-axis. So as we want to attach a negative in to indicate a reflection, when things move left and right, that's a horizontal shift, I'm going to attach a negative directly to x. Finally, when we want to move everything up 4 units, that's going to be a vertical shift. We're going to attach a 4 to the entire function to move everything up 4 units. Now, if this is said down 4 units, this would be subtracting 4 at the end. Again, 3 individual questions. Now, if I want to put them all together into a single, like if we were asked to apply all 3 of these transformations, that would look like 2e to the negative x with a plus 4 at the end, basically including all 3 of these different transformations. Now let's see if we can answer the question about the domain, range, and horizontal asymptote. Okay, the domain is always going to be negative to positive infinity for all of these exponential functions. The range is somewhat dependent on the horizontal asymptote. Now a stretch or a horizontal reflection, those do not affect our horizontal asymptote. However, moving either up or down, that will affect it. So it started on the x-axis when y equals 0, but we've moved everything up 4 units. So that horizontal asymptote is now going to be located at y equals 4. Okay, in thinking about all these transformations put together, a stretch doesn't affect the range. The reflection horizontally is not going to affect the range, and the shift up does affect the range, but it didn't get flipped upside down. So in this case, this is going to be from 4 to infinity. It's still going to be above that horizontal asymptote. All right, a very similar question on this next one. Again, we're starting with e to the x, but we're applying these 3 transformations. So very similar. First of all, the compression, or it's been compressed vertically by a factor of 1/3. We can say that's 1/3 times e to the x to just apply this one transformation. Again, reflect about the x-axis. Good reminder which one's the x-axis, which one's the y-axis. When you're reflecting about the x-axis, things are moving vertically. So reflections always indicate a negative, but this time that negative is going to get attached to the entire function. So things did get moved vertically. So our e to the x graph got shifted vertically. So now the negative e to the x would be below the x-axis. And the final shift, let's shift everything down 2 units. So if we start with the e to the x, we want to move everything down 2 units, you're going to subtract 2 from the entire function. Again, like we saw up above, if you want to move everything up 4 units, you attach a plus 4 to the entire function. Now, if this had been left or right, something would be attached directly to x, and that kind of works counterintuitively to how we think it should. Putting this all together, if we needed to, we could say a function that includes all of these transformations, you'd put a negative out in front attached to the entire function. Same thing with your 1/3, e to the x with a -2 attached to the entire function. Again, that's if you had needed to apply all three of these to the function. Okay, domains always negative to positive infinity on these exponential functions. The horizontal asymptote is only affected by this vertical shift. So it's going to be at y equals -2. Now we do have to be careful about our range, that negative has flipped the entire thing upside down, and then it got moved down 2 units. So this graph is going to be below the horizontal asymptote. So you can say it goes down to -infinity. And the highest value it almost gets to is that horizontal asymptote at -2. On both of these sides, we never quite get there, so we use the open brackets or parentheses to indicate that. All right, hope this helps out in understanding where to attach numbers in to apply transformations to functions. Good luck to you on it.